Assalamualaikum to Dr. Muhammad Aimullah bin Abdullah. We are from Group 2, gonna present about Case 4, which is electricity pylons falls during storm. Our group members, our group member is Muhammad Daniel Adam bin Muhammad Nazri, CN210277, and me, Muhammad Haris bin Ismail, CN210382, and last, Ahmad Ali Muaz bin Bani Yamin, CN210400. Okay, today I'm going to present about chapter 1, which is introduction. Okay, the background. First, a transmission tower, also known as an electricity pylon, or simply a pylon in British English. In another region, we call it electricity pole. A pylon is a tall structure, usually a steel-lated tower used to support an overhead power line. In electrical grids, they are generally used to carry high voltage transmission line that transport bulk electric power from generating station to electrical substation. Okay, third, most electricity pylons are 35 feet tall, although their heights can range from 20 to 100 feet. Modern utility poles are usually concrete, steel or fiberglass and last longer than their wood counterparts. In addition, poles are buried 6 feet in the ground and spaced about 125 feet apart. Next is problem statement. One of the problem statement is to determine the cause of pylon or a transmission tower fall during the storm due to the type of structure and material that are used to make the transmission tower. Even though the power line in urban areas tend to run at lower voltage, it still has the potential to cause injuries if you touch these lines. Electrical shock can lead to severe internal damage and even death. You don't have to touch a wire to get an electricity shock. 3 branches can come in contact with a power line and energize the tree and the ground around it. Although poles are sturdy, they don't last forever. Insect damage, high wind, old age, or inclement weather are all factors that can lead to pole cracking. When this happens, a transformer can come crashing down, cause injuries and property damage. Beware of poles that are leaning and report them to your local utility company. Chapter 2, Methodology. The related theory is the resultant force. We must find the resultant force to make the pole sturdy. Okay, the formula of the resultant force is F1 plus F2 plus F3, and we can conclude this as a Fr. Okay, as we all know, the force and motion are fundamental to all matters in the universe. A force is anything that can push or pull an object. Second, force influences objects that are at rest or that are already in motion. These laws involve inertia, mass, velocity, and momentum. 3. A force is required to do work, and generating a force requires energy. Energy can be stored as potential energy, or it can have kinetic energy, the energy of motion. Energy can also be converted and exchanged through energy transfer. For example, 2 forces of magnitude F1 and F2 act upon a particle. This type of theory is related to the case that our group project, which is to find the resultant force of a pole. Okay, before we can calculate anything, we must first draw a free body diagram. In this utility pole, 3 cables apply on the utility pole to make sure that the pole didn't fall. 3 cables will give a low magnitude that applies on the pole. It can make the stability of the pole to be higher than before. The value of resultant force we can find using the calculation that is suitable for this problem. Treating the whole configuration as a rigid body, draw a free body diagram as I mentioned earlier, and the free body diagram is on the right. Writing down the resultant vector equation and solving the magnitude force that acting on the utility pole. Last, this analysis does not vary from a single rigid body analysis. As we can see here is case 1, which is 2 cables. First, we must draw a free body diagram, which we can stretch out the 2 cables, which is force 1 and force 2. And we calculate them and get a resultant force. Okay, as we all know, 2 cables are not strong enough to maintain the rigid body of the pole. So, in case 2, we use 3 cables, which is F1, F2, and F3. We added one stretch of cable. Okay, if we want add one stretch of cable, this will make the rigid body of a pole strong and can maintain a harsh weather. As we can conclude in this calculation in methodology, we can conclude that 3 cables are stronger than 2 cables.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Din Adam bin Muhammad Nazri. My metric number is CN210277, and today I will go on to the chapter 3, which is the result and discussion. As you can see, this is the explain table that we get after solving the case 1 and the case 2. We can see that the case 1, the resultant with force that we got is 256 Newton, and for the case 2, we got 403.42 Newton. Then we go. This is the graph force against number of the cables. In case 1, we utilize 2 cable in instance 1 since it is a 2 force member. 2 force member is defined as an element with pins or hinge supports on both ends, no load in the middle. And that is called the 2 force principle. If just 2 forces act on the balanced body, they must be of equal size, called linear, and opposing in direction. In case 2, the 3 force members is formed when the 3 non-parallel forces engage on the body in equilibrium as in instance 2. In order to maintain balance, the 3 forces interact with the structural member in every particular way. As a result, the 3 forces operating on such a member must coordinate their action. A 3 force member is typically an element with 1 load and 2 responses. These members are frequently subjected to stresses and produce bending, as well as extra strain and compression. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Nama saya Ahmad Ali Muaz bin Bani saya akan membentangkan chapter 4, Suggestion and recommendation. 3 cable in our perspective will generate a low magnitude that will be applied to the pole. It has the potential to improve the stability of the pole. However, because the magnitude is low and the force is minimal, we propose using only 2 wires. The result pole will become more stable. Delaying a pole inspection can have long-term and damaging effects for asset owner and their business. Conclusion: the calculation that we perform in the calculation section is essential to determine the utility pole's limit. The impacts of climate change on deterioration, hurricane risk, pole failure, and replacement rate were also investigated. The use of global circulation models that can mimic storms or hurricanes is required because of this association. In static education, 3 cable will produce a low magnitude that will connect to the pole. It has the potential to upgrade the pole's stability. We can find the value of the resultant force problem by using the calculation that is correct for this situation. Consider the entire arrangement to be a rigid body. Create a free body diagram. Write out the consequent vector equation and solve the magnitude force operation on the utility pole. This study differs from a single rigid body analysis in no way. This is a figure 3 free body diagram.